Hey, I hope you are well and doing good. And in this video, we will start recursion. Now, recursion. When a function call to itself directly or indirectly, that is known as a recursion. And let's consider as a real life example. In our class, there is many student, like as 30 student, and if I am calling to any student, means I am calling to a student, like as a hey Rajan, come, hey Sunil, come, hey Tanu, come, hey Bandana, come, means I am calling to a student. When they will come, then I will stop to calling him. But when I am calling to myself, has Javi, means I am calling to myself only. Means I am calling to myself only. And when I will stop to calling myself, there should be any condition. Means suppose that there is a condition, I am calling to myself only 5 times. After 5 times, I will not call to myself. Means when I will call has Zevi, means after 5 times I will stop to calling myself. That is recursion. Okay, now let's understood the with the help of example. Suppose we have to find the factorial of any given number. Okay, and then we have to return type, then recursive function. Okay, and function. Okay, and there should be anything I will discuss, and function that will, and there is should any statement. Okay, now this function in our program, this function will calling to itself. This is calling to itself again and again. Function is calling to function again and again. Okay, and when it should stop, that time we have to mention a base condition. Base condition is defined when this calling function will stop, terminate to calling itself. Means there should be a base condition. There should be a base condition. Okay, after mention the base condition, we have to define the recursive functions and recursive case. Okay, then we have to recursive case, means when we implement, how we will solve this problem, then we will implement this case. And after this case, if there is any statement, then we can implement any statement. Means the basic things, that is return type, function name, base condition, and recursive condition, and function which is calling to itself. If base condition is met, then we can out of this condition. Okay, now consider, we have to suppose, first of all, we have to find the factorial of 5. Then we can write it 5 into 4 into 3 into 2 into 1. Okay, and 4 factorial, 4 into 3 into 2 into 1. We can write it. Now we can we have to find the 5 factorial of 5, means 5 into factorial of 4. We can write it factorial of 4, means 5 into factorial of 4. Okay, now here if we will see, then 5 into 5 into what is, it is the 5 minus 1 factorial. Okay, and if you have to find the any given n number, then what will write here? Factorial of n is equal to n into n minus 1. This is the case to solve the factorial. Okay, and only we cannot solve the from this. We have to mention the base condition. Now here we will implement int here factorial and we have to pass int n. Okay, then base condition, and we are going to increasing 4 3 2 1, means when we reach at the 1, then we have to return, means our base condition is 1. Then int if n is equal to 1, then we have to return. Okay, when we reach at the 1, then we this function will be returned. Okay, now and we have to implement this now here. Then factorial n is equal to, it will be n into return n into factorial of n minus 1. Okay, this is the only condition where when this is the base condition, our base condition, and this is the recursive function, recursive case. That's better, recursive case. Now first time it is n is, or suppose 5, then 5, and we'll implement with the help of a stack. Okay, here is our stack. In our stack there is a main int, here is a main function. Okay, and when this recursive function will call, it will be create a stack, and this will be create at the first time, means n into factorial of n minus 1, means starting it's 5. Suppose n is equal to 5. Okay, then here int 5 into 5, and this is into 5 minus 1, means here 5 minus 1, means it becomes 4. Okay, now again it will be called to itself, then a stack will be push up. Now n is equal to 3, because 4 minus 1 3, and again it will be a stack will be push up. Now n minus 1 minus 3 minus 1, it's become 2, again it will be push up, it's become 1. Okay, now this is our condition, n is equal to 1, then we have to return, then it will be return here, then 1 into 2, means it's a 2. Okay, and that will be returned to here, then 2 into 3 6. Okay, and here 6 into our number is 4 means 6 24, here 24, and 24 are multiplied with the n means 5. 24 into 5 means is equal to 120 and 120. And when it will be returned, then it will be pop out, means this is pop out. Then when it 2 will be returned, then 2 will be pop out. When 3 will be returned, then 3 will be pop out. When 5 will be returned, then 5 will be pop out. And in this is main, and it will be returned here 120, and only we have main, means which memory has been used, this will be popped out, and only we have it will be returned 120, means factorial of 5. And in the main function we should call it, and like this I will write it int main and int result and factorial 5 and print cout result, okay, and return 0. That is okay. And in next video we will see the indirect way and direct way to call itself, and also recursion tree. We will see recursion tree and backtracking, okay. And there is a things when we have the iterative functions, we can solve a problem using loops. Then why it's the comes recursion function? That is the mainly one point. There is a if there is a big problem, then we can solve only one part of the problem, and we can call to itself. That will be recursion will be control these things, and control will be solve this problem. Here only we have solved only one part. Here n and n into n minus 1 means only we have multiply in 4, okay, 4. Here is not a factorial, only we will multiply 5 into 4, but this function will call to itself again and again, and it will be increment 1 minus 1, it will be reducing 1 by 1. Only we have solved this problem, only one step we have solved. There is a one solved in the recursion. We have to solve only one function, only one step, and remaining step will be recursion will be solved, okay. Now thank you.